Okay, today we thought we would go ahead and talk about a system of linear equations where y or x has not been solved for. So as you can see in these two equations, both x and y are on the same side of the equation. So what we're going to do is we're going to take and solve for one of these x's or one of these y's. And what I like to do is I like to look for the y or the x which has a coefficient of 1. And by that, the coefficient, I'm talking about the numbers in front. Obviously, this is not a positive 1. And this coefficient's not a positive 1. This coefficient actually is a negative 1. And this coefficient is a positive 1. So this is what I'm going to solve for. So I think the easiest way to solve for this is to isolate it, which means we need to get rid of this negative 4x. And the opposite of a negative 4x is a positive 4x. So we simply add 4x to each side. So in doing so, this part right here goes away, it cancels. So we're left with y equals 6 plus 4x, or if you would like, you can put y equals 4x plus 6. And now we're simply going to follow the same procedure that we did earlier, where we're going to take this value and plug it into the second equation for y. So we have negative 5x, which we leave the same, minus 1, and then in parentheses is what I'm going to replace with the 4x plus 6 is equal to 21. So now you can see that we have an equation which just has an x in it, and the y has been substituted for. Now, the trickiest part of this is that you must distribute a negative 1 here. This is a problem that I've seen over the years. A number of students, they'll just distribute 1 and not a negative 1. So a negative 1 times a positive 4x will give you the negative 4x, and a negative 1 times a positive 6 will give you a negative 6. Bring down your negative 5x, bring down your 21, and at this point we can combine like terms. These two x terms can be combined. Negative 9x minus 6 is equal to 21. And we're back to a simple two-step equation. We have multiplication, we have subtraction, we undo subtraction first. So we will add 6 to each side. Opposites cancel, leaving us with negative 9x is equal to 27. We have a multiplication equation. To undo multiplication, we divide. So we divide each side by negative 9. The negative 9's cancel, leaving us with x. And 27 divided by negative 9 is negative 3. Now, all of that work, and we still have more work to do. Because ultimately, we want to end up with an ordered pair. The only value we have is the x value of negative 3. We need the y value. So we're going to have to take this value and plug it back into either of the original equations or the solution of y. And I choose to use one of these two. So I'm going to take the negative 3 and I'm going to plug it in right here. So we have 6 plus 4 times negative 3. 4 times negative 3 is negative 12. Plus the 6 will give us positive 6. So y equals 6. And 6 goes here in the ordered pair. And this is our final solution. Keep in mind that when we solve a system of linear equations, we are looking for an ordered pair which represents the intersection of the two lines. And that's part of that big picture. So just because you end up with this as your solution for x, you still have a little bit more work to do. Good luck.